Right, so in this video I'm going to have a look at integration by parts. Now, very often you'll come across functions that are products and they can't be integrated normally by substitution, for example. So you need to use a different method to integrate them, and we're going to use this method here. Now, this is really just it's really just a product rule in reverse, if you like. So let's just have a look at proving this particular formula here that we're going to use for integration by parts first of all. So let's have a look at our basic function. Let's call it y, and that's u times v. So let's look at differentiating this first. So if you differentiate y, you get dy dx, and that's just our product rule. It's going to be u dv dx plus v du dx. Now let's look at integrating both sides with respect to x. So that would give us the integral of dy dx with respect to x, the integral of u dv dx with respect to x, and the integral of v du dx with respect to x as well. So we've integrated each of these terms in this equation. Okay, so our next line then would just be, well, you can see we've got the x here, so that will just give us the integral of dy. On this side, look, we've got the x here and the x here, so that's just the integral of u dv. Over here we've got the integral of, we've got the x here and the x here, so we just end up with dv du. Okay, so now if we do the integral on the left hand side here, we get the integral of 1, if you like, 1 dy is just going to be y. The integral of u dv, we leave that here, the integral of u dv plus the integral of v du. Okay, now we know from the beginning here that y here, look, y is equal to uv. So instead of y here, I'm just going to put in uv. So uv here is equal to the integral of u dv plus the integral of v du. Okay, and you can probably see where this is going at this stage. That will give us the integral of u dv, the integral of u dv here. So that's this one here. I brought this over here, changed the sign to, it would have been minus, I've changed it back to plus, you'll see that in a second. So I'm going to bring this over here, which will become minus, I'll change it to plus as well, so that is uv. Because I've changed signs a couple of times here, I'm going to change this sign as well. That's minus the integral of v du. So that's what we started with. The integral of u dv is equal to uv minus the integral of v du. So this is our formula we're going to use to do some integrations that we can't normally do by substitution. Now, just one other thing that you need to be aware of when you're doing integration by substitution, or by parts rather, you're going to have to rearrange the functions within the function that you're integrating. So for example, well, we'll do an example in a minute. Let's just do the order first. So you're going to have to put them in this order. You're going to have to do inverse first, put inverses first, then you're going to have to do logs, then you're going to have to do any algebraic sections, and then trigonometric, and then exponential. So it's called the inlate rule, the inlate, I-N-L-A-T-E. So these are inverse, these are logs, this is algebra, this is trig functions, and these are exponential functions. Okay, so it's called the inlate rule. So you need to order your functions in this order here before you start using this particular rule here. Okay, so let's have a look at one or two examples. So let's have a look at the example. Let's see. Okay, so we'll go for the one I mentioned earlier, x e to the power of x here. Now if you try to do substitution here, it doesn't work. So you're going to use this particular rule here. Now, I'm just going to write it down again here. I'll just write it down in green here. So our integral of u dv, so our integral of u dv is equal to uv minus the integral of v du. So this is our rule here that we're going to use. Now, okay, so let's start. The first thing we need to do is look to see, do we have this in the correct order, these functions in the correct order. You can see there's a function here and there's a function of x here. So this here is an algebraic function. So here's algebra here, and this here is an exponential function. So algebra functions come before exponential functions, so this is in the correct order. So we can proceed with our formula. Okay, so let's start. Now, what we're going to do is let u first of all equal to x. We have an x here and an x here, so let's do that. So let u equal to x. U is equal to x. So that would give me du dx. Du dx here is just going to be 1. So that will give me du is equal to dx by cross multiplying here. Okay, what about dv? So we're going to look at dv then. Let dv equal to, so remember we let u equal to the x here, so we're going to let dv equal to the remaining part here. That's e to the power of x dx. dv is equal to e to the power of x dx. Now if we integrate both sides of this particular equation here, so the integral of dv, in other words, the integral of dv is equal to the integral of e to the power of x dx. What do we end up with? Well, this is 1 dv. So if you integrate 1 with respect to v, you get v. And if we integrate e to the power of x, we get e to the power of x here. Okay, so we have everything we need at the moment to proceed. So let's continue on then. So we want to fill out the bits and pieces here for our formula, so let's do that. So I'll just leave it here. Yeah. Okay, so we need the integral of u dv, the integral of u dv. So u is equal to, I'll write it down here, I'll write this down again. So we have the integral of x e to the power of x dx. Okay, so what will that be equal to then? It's equal to, so we're doing this here, remember? So u dv here, u is our x, there's our x, and dv is e to the power of x dx, so that's this part here. So we want u times v, well u is x, so we're going to write down x here. V here, this v here, is e to the power of x, so that's going to be e to the power of x here. We've got our minus here, and then we want the integral of v, the integral of v. Well, v is e to the power of x, so we want the integral of e to the power of x, and that's it, really, the integral of e to the power of x dx. Okay. Now, so let's just have a look at that then. So we have, let's just move this up a little bit. Okay, so this will give us x e to the power of x e to the power of x here, and now we want to integrate e to the power of x, so that's just going to be e to the power of x, and then because this is an indefinite integral here, we will have our c here as well. Okay, our constant of integration. Now if we want to check this, this is our answer here. Okay, so this is what we got when we integrated our original function. Let's see, do we end up, if we differentiate this here, do we end up with our final solution, our original function rather, of x e to the power of x? Will we end up with this if we differentiate this? Well, let's try it and see. So we want to differentiate this function here. So let's see, we have d, I'll just use the white again here, so we want to differentiate x e to the power of x minus e to the power of x plus c. So we want to differentiate this with respect to x. Okay, so if you differentiate x e to the power of x, this is a product here, so we need to use the product rule, so it's u dv dx plus v du dx. So let's say this is our u here, this is our v here, so I'll do that here. So it's u dv dx, so it's x dv dx is e to the power of x, plus v, which is e to the power of x, du dx is just 1. Now I'm going to differentiate this bit here actually, so it's going to be minus, you differentiate e to the power of x, you get e to the power of x, and if you differentiate the constant here, you'll just get 0. So if you look at this, what do you end up with? Plus e to the power of x minus e to the power of x, and we're just left with this bit here, which is x e to the power of x. So look, we did end up with our original function when we differentiated. Okay, so that seemed to work okay for us. Let's just look at one more example, and we'll leave it at that then. So let's have a look at the integral. We're going to look at the integral from 1 to e of x log of x to the base e dx. So we want to integrate this. Again, this is a product. We have this function here of x and we have this function here of x. Now the first thing we've got to do here is make sure they're in the correct order. So remember, logs, we're looking at in late. Remember the inverses in late, logs a, t and e. So we need logs to be before algebra. We have algebra before logs here, so I just need to switch those around. So this is the integral from 1 to e of log x to the base e, and that's all times x dx. So that's the order I want them in. Okay, so let's start then. So first thing we're going to do is do it in green here, I think. Let u equal to log x to the base e, log x to the base e. So if we differentiate, we get du dx is equal to, if you differentiate log of x, you get 1 over x. So that gives us du then equal to 1 over x dx. Okay. Now, we're letting u equal to log x to the base e, so our dv then, our dv is going to be the remaining part, this part here, which is x dx. Again, integrate both sides here, so if you integrate dv on this side, you're going to integrate x dx on this side. If you integrate 1 dv, you get v. If you integrate x, you get x squared over 2, or a half x squared. Half x squared. Okay, we have everything here now that we need in order to use our formula. So let's just write the formula down again, just to have it here. So our formula is the integral of u, the integral of, where is it again? The integral of u dv is equal to uv minus the integral of v du. Okay, so let's stick everything in here that we want. We want the integral of u dv, the integral of u dv, so that's going to be equal to u times v, u times v. So u is log x to the base e, so that's going to be log x to the base e, that's our u here. And that's times v here, which is a half x squared. So all of this times half x squared here. So this is u times v, minus the integral of v, which is a half x squared. Half x squared, that's this bit here. And that is times du. And du here is du is 1 over x dx. 1 over x dx here. So we got to put that in as well. So 1 over x dx here. Okay, so that's everything included at this stage, so let's just do the individual bits then. Right, so log x to the base e times half x dx. I'm just going to take this and bring it around to this side, it'll be easier. Half x squared, and that's all times log x to the base e. And now this is going to be minus. What I'm going to do here is just take the half outside the integral symbol here. You can do that with integrals, so that's going to be a half. And now I have here, I've got an x squared on top here, so that's x squared over 1 if you like. I've got an x here, so really that x will divide into that x squared, and I'm just left with x here dx. So that makes things a little bit easier. Okay, so let's look at the next line then. So here I've got half, got x squared, log x to the base e. Here I've got the minus half. If I integrate x, I get x squared over 2, or another half if you like. So that's it. Okay, so now we've done the right hand side here. Now what I'm going to do is just put in the limits here. So I think initially we had, let's see, yeah, initially what we started here was with our limits were e and 1 here, so I got to put in these limits now, okay? So let's do that. I'm kind of running out of room here, but we'll try and squeeze it in here at the end. So I got to put in limits here. Okay, so I have my, I'll just put a line here, and I'll just put in the limits here, which are e and 1 here. So what you've got to do here is put e in here, here, and here, and then put 1 in here, here, and here, and subtract the 2. So what you end up with is, now this is going to get a little bit, just going to squash it in here a little bit. So you've got half, you've got an e to the e squared here, you've got an e squared. Then you've got log e to the base e, that's just simply going to be 1. So I'm going to put a 1 in here, minus a half. Now you've got e squared here. So this is a quarter, this is a half, 2 times 2 here is just a quarter, so actually what I'll do here is just put in a 4 here. This is this 2 times 2 here. And then I've got e squared on the top here, so I'm just going to put an e squared here. Okay, so that's our e substituted. Now we want to stick in 1 here for x, so it's going to be a half. You got a 1 squared, which is just 1. Now you've got a log of 1 to the base e, that's just going to be 0. E to the power of 0 will give you 1. And over here then we have 1 over 4 1 over 4 here times 1 squared, so that's just simply going to be minus 1 over 4. Okay, so now we've substituted our e and our 1 in, and what we end up with is a half e squared minus a quarter e squared plus a quarter. Okay, and what I'm going to do then is just I'll just come over here again, so that will give me a quarter e squared plus a quarter here. Now I'm just going to factorize here, so that will give me a quarter, that will give me e squared plus 1. So that's it simplified. Now you can check that as well yourselves. I've kind of run out of room here, so I'm going to leave it at that.